It's really wonderful to be here tonight and to see someone I haven't seen in a while. So let's start with an introduction, Guy.
Well, hello everyone. My name's Guy Davidson. I live in England. I live on the south coast of England. I live 60 miles south of London in a city called Brighton and Hove. I live in the Hove part of Brighton and Hove, and I've been writing software since 1980 when I started learning about programming at school. One day a computer just turned up at school and I thought, well, what's this? What's this? And I was absolutely wrapped up with it. I've been mainly writing games since 1980, and I am now the convener of the C++ committee, which I absolutely was not expecting this time last year, I can assure you. However, it's proving to be a remarkably fulfilling job. I'm absolutely loving it. I took over from Herb Sutter at the end of last year, and I took over a well-run committee, a well-functioning committee. Herb was a tremendous convener. He had the job since, I think, 2002, which is an enormous amount of time to be doing this. I inherited an excellent leadership team. We have a number of study groups with a lot of chairs, and all of those chairs are excellent people. A few people have chopped and changed because they decided, do you know what, I'm stepping down as well. But we have a really good leadership team. And it's a purely administrative role. I didn't get this job because I'm the best C++ programmer in the world. I'm not at all. There are many better C++ engineers on the committee, as well as everywhere else than me. But I'm in charge of just herding the cats, just making sure that we line up and deliver a new standard every 3 years according to our train model. So this is part of the International Organization for Standards, the ISO, and they've been standardizing C++ since 1988. 1998, not 88, since 1998. It's an international organization, which makes me happy, as I'm very much an internationalist. And I am a European, even though I live in Britain.
That's interesting to hear. So basically, you're now the chief C++ bureaucrat, and your role does not have so much to do with C++. It has to do a lot with organizing and finding someone who wants to host a meeting.
Yeah.
Which used to be a fun activity, I heard from Hannah, who's doing it for the second time.
She is doing it for a second time in Brno in Czechia at the end of June, middle of June.
That's right.
And I have high hopes. I've never been to Brno. I'm really looking forward to it. But you're right. My responsibilities are for convening meetings and calling consensus. So I get to say, right, we're meeting here at this date, and also when votes are taken in closing plenary, I get to say, yes, that vote passes. Now, so far, I've had to do this at 2 meetings at Coda last year, which is why I couldn't be at meeting C++, and at Croydon, where we just sent the working draft off for transmission to our parent body, ST22, who then send it out for ballot to the national bodies. So yes, I don't really need to know much about C++ for that, although obviously it helps, when people are making contentious decisions or dicey statements. I need to be able to say, no, I think you'll find references don't behave like that at all. You need to be able to keep people on the straight and narrow. So it's not a job anyone could do. I've also started attending C meetings, WG14. C++ is working group 21. C is working group 14. Robert Secord is the convener there. He also has quite a beard, but he's stepping down. And there was a fleeting moment where I thought, you know what, I could take that over as well. I could run both of them, and I could get rid of implicit conversion or something like that in both languages, and the world would be a better place, I'm sure. But frankly, it's a silly idea.
Interesting.
Yeah, I'm not going to do that.
It's actually like a thought I had for some time. It's like basically the C++ committee has become so huge, and the C committee is still so small that if just a bunch of people from the C++ committee would go to their meetings, they basically.
Yeah, It is absolutely enormous. The global directory has got hundreds and hundreds. I think it's got like 500 people in the list of experts. C++ is it has 15 million users worldwide. At the sort of best estimate. C maybe has more users, but it has a less active standardization community. And maybe that's a good thing. C is a smaller language; it has a smaller purview. C++ is basically frontier stuff. This is where we're trying stuff out. It would be interesting to co-locate the C and C++ standards meetings, and actually, I think that's going to be happening in November in Brazil. It'd be good to see what happens. There are people who sit on both committees. Nevin Lieber, for example, he attends both. And Jan Schultke, who is a sort of rising star in numerics, and he works on floating point stuff. I think he attends both too. So there is some crossover, but we are the 800-pound gorilla in the room of language standardization. Prolog. Prolog is standardized. Fortran is standardized. COBOL is standardized. Ada is standardized. I think there are 9 people on the Ada committee. So C++ is the king of the jungle. It's the runaway. It's a runaway juggernaut, frankly. So many people throwing stuff in there. No, sorry, carry on. I can just talk forever, really. Yeah. Do stop me, Ed. You know me.
The king of the jungle. I see the headlines tomorrow. So our latest product in C++ standardization is C++ 26.
Well, the thing that gives me lots of things give me
which is currently in the making still.
In the process, yeah. We sent it off to ISO and said, right, there you go. We're going to carry on, but you published that one. What gets me excited? Well, if you've been watching any videos from any conferences over the past year or so, you'll have a pretty good idea of what's going to be in there. So the way that we standardize is that sort of 1 year ago, we said, right, stop. We stop adding new features, and we send out a committee, what's called a committee draft, and then the national bodies get to comment on it and say, oh yeah, less of this, more of this. This is wrong. No. This is great. And we spend the following 2 meetings fixing that up, and that's what we've just done. So there's already been a lot of stuff that's in C++ 26 that has been trailed in conferences, and that's great. I want people to become excited about C++ 26 because there are some exciting features in there. The headline one, obviously, is reflection. This is the magic feature that's going to take us forever to work out just what we can do. This is like, I remember when. Sorry.
Yeah, I know. I've been working on reflection the last weeks and writing content about it, and it's not yet released. It's wild what people already do in blogs. And
I remember when template metaprogramming first appeared, and looking at this and thinking, oh my goodness me, this is what on earth is going on here, and thinking how but the power that we've achieved with template metaprogramming, the ability to write truly flexible, truly abstract code is immense. It's been one of the for me, it's been one of the big drivers of C++. But now, kind of formalizing that still further into reflection is a tremendous move. And it's compile time. It's not runtime. It's compile time reflection. Honestly, it's a miracle of the modern world. And the whole reflection team, Daniel Katz and Barry Rebs and David van der Voort, all of the people. We need to look carefully upon their gaze and cower within it, because it really is quite something. It's the product of remarkable intellect and foresight and vision, and I'm delighted reflection is coming in. But it's not just reflection, of course. Contracts, which has been somewhat controversial inside the committee, but contracts is looking great. The whole safety aspect of things really is. One thing that the committee does, and which I think people don't give us enough credit for, is that we listen and we adapt. When people say, well, our C++ is rubbish, it doesn't do this or that, or it's slow, or it's too fast, or it's too complicated, we try and fix stuff up. get accused of throwing too much into C++, but an awful lot of what we throw in simplifies C++. It doesn't complicate it, you know. And there's this thing, you've got to be careful that you don't confuse simplicity with familiarity. You know, when the range-based for loop came in, people were saying, well, what's this for? We've got a for loop. Why do we need the range-based? This range-based for loop is far too complex. But of course, it's not complex. It's much simpler. It much more clearly tells you what's going on. Here's a set of things. Go through them. You know, it's a range. Whereas beforehand, you'd have the index and the condition.
If you think about it, the range-based for loop is what gave us God bold.
Yeah, absolutely. That is exactly correct.
That would be the best C++ feature we ever had, right? And I think personally, with reflection, you can very easily get started and play around on Godbolt on Compiler Explorer.
Yeah.
Contracts I haven't played around, and I don't know where and how. And I think, especially the last weeks, I've been looking at modules, and modules also is, and contracts is for me in some ways similar, that it is not something which is a normal C++ feature, which is just compiled, but it actually then has an influence on the compilation and the RV, etc., potentially, and is for sure going to be a controversial feature, like exceptions. And
yeah, absolutely. Yeah, I mean, you know, Compiler Explorer is one of the wonders of the modern world, isn't it? You know, Matt Godbolt is our local hero who's given us this great toy for solving arguments. It's fantastic. And it's meant that we can look at branches of Clang and we can, you know, write code with them and try stuff out. It's fantastic. I'm delighted Compiler Explorer exists. And I'm delighted that reflection has been made available so early and so frequently. You know, it's been regularly updated. We know what's going on. We can do things like that. And you're right. Reflection is the kind of feature that it's just a new construct that you put into your code. And it's easy to see what's going on. Contracts and modules, they're more structural features that tell you that dictate how you design your APIs or how you arrange your code and lay things out. So I think, yes, you're right. Modules and contracts, they are of a piece because they're a little bit more abstract. That doesn't stop them from being immensely useful, of course.
It takes a bit of work, but you can get modules also working on Compiler Explorer.
Yes.
And if you try this from scratch, you will probably go a little bit of insane because the compiler errors are just terrifying, and then you need to you need to add the compilers again and delete the old ones you already had in there, and then somehow it starts working. Just before that, it's just the clash of things, of setups and the tool itself.
Modules, I think. I keep hearing people say modules aren't quite ready for prime time, and in my own place of work, we're not on the modules train yet because we're using too many compilers. And I've only used modules in sort of small examples. I'd be delighted to hear about, you know, proper industrial feedback on large scale use of modules to see what, you know, see how the usage has worked out. You know, the module story is just part of the larger, you know, packaging story and you know all of that tooling, you know, which, you know, I fully agree is something that we've needed for a very, very long time. And, you know, other languages are beating us hollow on that.
One thing I've noticed is last year there was very popular to rant about modules, how things are not working and how modules are not ready. That was the topic of 2025 in the blog sphere about C++. And this year it seems to be more structural, people trying it out and what's still not working or which tools are not working, but it's more detailed and it's not a rant anymore. It's more productive. We seem to go into an area where modules becomes more available. And then maybe, you know, we will have to adopt things into C++ 29 for modules because some things might need to change. So I wondered, of course, you know, it's all the great 26 features which hopefully find their way in to the compilers. And that's like one of the great things I think is that reflection actually is already available in the current trunk of GCC and Clang and working on Microsoft compilers. So what's kind of the things you see in flight that are going to be part of 29?
Well, do you know what? That's a really good question, because I was thinking about this, during the day, looking at the papers that are coming through. I think one of the big ticket items may very well be networking. Finally, at last, we might start getting some proper networking support. There is some, extensive, very enthusiastic efforts being brought to bear to improve this. And to be honest, I still find it slightly embarrassing that, out of the box, I can't open a socket, to a web page or to anything with C++. I've got to choose a library, or I've got to, spin up some OS code or something like that. So, networking, I would very much like that to be part of C++ 29, because it's just about time. One of the features that was in C++ 26 is stud execution, which I haven't mentioned, which is a complex feature. I have considerable difficulty teaching it. To be honest, I have considerable difficulty understanding it. It's one of those things where you just have to implement the feature yourself. And once you've implemented the feature yourself, then you can teach it. I have not done that. I know a few people who have. And I'm inclined to believe fewer than 10 people on the planet have implemented stud execution. Actually, maybe fewer than 20, but it's a very small number. But this is going to feed into the networking story. Also, improvement of coroutines, improving the coroutine model, that can also, fit into the networking story. I'll be interested to see how that all turns out. There's been talk of improving pattern matching. There's a pattern matching proposal in flight that's been, it's not fallen to the ground, but it's in limbo at the moment. It's suspended. I'd like to see that one picked up again, because I think that's a great simplification feature that we can benefit from enormously. And as I say, simplifying is the thing. CPP2, which Herb Sutter's been working on his own, he's got a kind of pattern matching working in there, and it just leads to much more readable code. Switch case statements are vile, ugly things. And if you've got a switch with more than 6 case statements, the chances are it's not doing what you think it's doing. It's one of those things that stuff goes wrong there. This is one of the reasons you write virtual functions, is so you don't have to write switch case functions, switch case statements. So yeah, I would like to see pattern matching getting in there. Profiles, obviously, the whole profiles effort is starting to hot up. My own, my employers are starting to work on this as well. And I would like to see, safety. Is there progress on profiles? Yes.
Yes. So actually, profiles. I'm sorry, but it's like, for me, that's like the ghost or the feature where I'm really not sure if it exists at all, because people talk about it, but it hasn't been visible so far to the community.
No.
In my opinion.
It's very much it's a theoretical feature. So yeah, profiles, again, it's not even a structural feature. Profiles are a way of compiling your code, I suppose. We have coding guidelines. I've even written a book about coding guidelines. We have all of these sorts of things, but they're hard to enforce, and sometimes you don't want to enforce all of them. Sometimes you're just not in a position. You want to enforce them selectively. And so the idea with a profile is effectively it's a command line switch, I suppose, that says, all right, for this set of source files, I need you to be absolutely bang on about safety, and I want you to make no compromises. I want you to, turn off optimizations or things like that. Or I want this, this set of files needs to comply with MISRA specifications. So the immediate thing that we need to be doing is static analysis. There are plenty of static analysis tools out there. So really, I suppose profiles it's about standardizing static analysis. That's what it feels like to me at the moment, which it seems like an unusual endeavor, but it's one of the things that we do with standardizing. Well, actually, things that we don't do with standardization. We don't standardize implementation. We don't standardize the command line. we're kind of moving into that a little bit. Well, not the implementation business, but moving into standardizing the command line or moving into how the compiler operates. That's really what profiles are doing, is telling the compiler to operate on this source file in a particular way, to pay special attention to features which are relevant to where you're compiling for. If you have particular guidelines that you must follow, then if there's a mechanism for performing static analysis to enforce those guidelines, that can be incorporated into profiles. And that's an important point about guidelines. A guideline is no use if you can't enforce it. Well, I mean, it has utility insofar as you can say, hey, don't do this, it's a bad idea. But it's very difficult to say, don't do this, you'll be rejected.
So profiles lives outside of the C++ code. So it's not like something which you can write profile and declare it like a module or something, right?
Well, there's a whole annotation. It's still up for discussion. I mean, there is annotation so that you can locally change the behavior of compilation in your source code.
Yeah, I've seen annotation. That's actually a really great feature of C++ 26 too, which is often like, first time I saw it, I was like, isn't that just, no, it's not. It's something different.
There are plenty of papers. Bjorn's got a paper, Herb's got a paper. There is an effort underway at the moment. We're trying to centralize all our efforts around a GitHub repository to build a branch of Clang which will support different profiles. So these profiles are things like a memory safety profile, a lifetime profile, an initialization profile. And that's a great thing that's got us to C++ 26. We now have erroneous behavior, rather than undefined behavior. We have erroneous behavior. So if you try and use something that hasn't been initialized, your compiler can say, well, no, this is erroneous behavior. That's if you tell your compiler vendor to do that. This is the other thing. It's all very well creating C++ 26, but you need to demand from your compiler vendor, I need you to support this, or I'm going to another compiler. The standard is large now. It's getting up to 2,600 pages, I think. And you can see implementers going, "Oh, that is a lot of work. When are they going to stop? When are they going to stop adding things in? Really, isn't the language big enough now?" And we're not going to do that. It's C++ is probably the primary area. It is the biggest source of academic research into programming languages that we have. There's such activity in there. We don't want to kill it dead. I think once you stop working on a language, that's pretty much it. It starts to rot as the future overtakes it. So I've gone right off topic here. Yes, there is progress on profiles. Watch this space. I'll be blogging about it. Herb will probably be blogging. In fact, everyone will be blogging about it once we actually have something that we can demonstrably show and write code that you can compile. Then you'll see us shouting about it from the rooftops.
Well, it's actually something where we might want to talk about is like, we're standardizing a lot, but we should standardize things which actually have also implementations, because especially with things like modules, we've seen it took so long to be available on other compilers, and one compiler presses ahead and they have the implementation. But what's the value of features that lack implementations? Especially 26 is a big standard again, and I wonder what features will have the short stick of being implemented in the 30s.
Yeah, that's a great question. Part of our process involves reviewing proposals that people make, and we will ask, what implementation experience do you have? This is particularly the case when we're standardizing library features, because we're living in an unprecedented age of experimentation, of availability to experiment now. We have two open source compilers, Clang and GCC, that you can patch stuff into. We have two open source standard libraries that you can play with. We're in a, we can be quite demanding. We can say in the committee, right, we want two implementations, please, of this, and we want you to tell us about the experience you had in implementing it. And for libraries, we can certainly say, well, how many users have you got? Have you got more than 10,000 users? Have you got more than 100,000 users? The best way of finding out whether or not something is worth standardizing is if it's already in wide use. We don't want to be designing features if we can avoid it. I mean, reflection was something that was very valuable, and obviously there was a lot of design that had to go into that. But design by committee is legendary for being a risky undertaking. I think in general, we've got it right. And I think one of the problems that contracts may have featured is that design by committee might have overtaken things there. There were too many dissenting voices. Because don't forget, contracts was actually in C++20 for a while, and then we suddenly realised that the authors disagreed over what it was we actually had, and there was a tremendous amount of work to pull it all out again. After closing 2019.
I think having worked with reflections, there is actually a few pitfalls, but I'm kind of happy about that, because you get notified that this is a deprecated code and that you should do it that way. And if you look at news sources, you see it the right way. But I've seen like almost a 10-year-old article which I wrote about the current way how to do reflections, which was, we use something completely different approach than what we do today. And today's approach feels much better, and it's like something which is a good first start. It's very complex already. You can do a lot, but we will add on top of that later.
Well, code injection is the obvious, follow-on from reflection. Once we've got reflection and injection, then, so Hannah was talking to me about this a while ago, and she was saying, wouldn't it be great to be able to write Python and then put it through a C++ compiler, to transpile from all of these languages into, into C++, and then, run it through the C++ abstract machine and optimize in that way. C++ could just become the Uber language, the lingua franca. Because at the moment, we communicate with other languages through C, for better or worse. C doesn't have, function overloading, which is awkward if you're trying to export functions to other languages. And actually, I think at last year's CPPCon, Herb spoke about this. Herb touched on this about, the things that reflection can do includes interoperability. I'll come back to that, actually. Let's actually focus on this question. Features that lack implementation. If a feature doesn't have an implementation, then it has no value, because it requires an implementation. And as I say, you need to tell your vendors which things you want to see. If you want to see modules, then you need to impress upon your vendors that they should prioritize modules. Hash embed or stud embed, which hash embed, the notion of embedding binaries in your source files. I started a campaign to persuade Microsoft to prioritize that in their adoption, and that's how you do it. You say to your vendors, look, we want this, please, because they respond to the market. They respond to what customers want. All of these things take time. I'm not certain that we have a fully compliant C++23 implementation yet. I haven't checked for a while, so I'm prepared to be shot down in flames by implementers who have actually done the work. But it does take a long time to implement these things, and certainly in the environment I work in, which is I make games. We were stuck on C++17 for a long time. On consoles. There was no sign of C++20 support emerging. You have to tell your vendors what you want. Vote with your wallet. So yeah, features that lack implementations, they're no use. We don't standardize anything that can't be implemented, or at least we try very hard not to. I can't think of any feature that has turned out to be unimplementable, because the bar is getting higher and higher for standardization.
That is true. So one thing I've saw in some proposals from the steering committee members is to go towards the goal of making the C++ of the future the AI language where AIs are implemented in. And I know you have a bit of a past in things, and now you basically, I wanted to pick your brain on that. Like, should we go for that? Should we have those float 4 and stuff like that in the language?
So, yeah, this is a lot to unpack. We do have a study group called Machine Learning Study Group, SG19. That study group at the moment is focusing on graph. You're probably familiar with Boost Graph. It's working on standardizing graphs, because that's fundamental to to large language model work. I think there is a danger of AI is a bit of a magic word. You just sprinkle AI over things, and money grows out of the pot. It doesn't work like that. I studied AI in the 80s, 80s and 90s. I was at Sussex University. My girlfriend was studying cognitive philosophy with Margaret Bowden. I didn't quite realise what a privilege that was until considerably afterwards. And back then, studying AI meant studying philosophy, epistemology, teleology, ontology, all of those sorts of things. And it surprises me how little I hear that being discussed in sort of contemporary AI. I'm old. We did things differently in the 80s. I'm not going to say that it was the one true way, but it does surprise me that people do struggle with definitions of intelligence. So I'm a bit of an AI skeptic, particularly with I don't want to dump on AI. Lots of people find it very useful. I think it's just the phrase AI just makes me itch a little bit. Nonetheless, we have, it's there. It needs support. And it would be great if C++ was the language that people chose to write their AI implementations in. I'm not sure that it's not the case, to be honest. I don't know what people are using instead.
No, I think it is the case, but there's a group of people in the committee which wants to support those people better. And I think that in a certain way, if we add some types they use into the standard, that's a good thing. And on the other hand, we recently, completely different to that topic, we had a debate about performance in C++. And it is the way that the people which have the job to only do performance in C++, they don't use standard C++ or the standard library so much because they have to go way more deeper than what we can offer as a generalized solution from the committee. They don't want to rely on a committee-based implementation for certain reasons.
No, and certainly games was like this.
If we want to cater to those people, if that's a valuable time for the committee.
I'm familiar with this point of view. So certainly in the 2000s, games was like this. You would not use the standard library in game development because everything was the implementations were very poor. Well, I don't know they were very poor, but we could do better, and that's what we did. And so lots and lots of people re-implemented large chunks of the standard library for their own use case. But the thing is, they had a vocabulary with which to do that. So rather than having stud vector, we had, I worked at Creative Assembly, we had CA vector, or we had CI dynamic array, or things like that. One of the advantages of standardizing is it does give people a common vocabulary. It gives, it improves interoperability. One of the things I want to see in C++ 29 is I have a proposal for small vectors and matrices for geometry usage. And it's one of those, why on earth would you standardize this? Because surely, everyone just writes their own. It's a really easy item. But the thing is, because everyone writes their own, it's very hard for me to share a piece of code with somebody else because they'll need to, change the names of things. If we declare a vocabulary and says, look, it looks like this. If you want to write stud vector 2f yourself, give it this interface because that's the one everyone's expecting. Then that actually, it serves a purpose. So standardizing vocabulary is useful for interoperability. That's something I'd like to be looking into during the course of the next standard. So, if we receive proposals, then great. It's all very well having a directions team, having a directions group, declaring priorities. And I'm pretty sure they're smart people. They know what's good for C++. They've been on this, they've been in this circus for a long time.
Mm.
But we are a voluntary organization. People will bring what they want to bring. And I will help and encourage and foster anybody who wants to attend to some of the priorities that direction group offers. I will absolutely welcome all enthusiastic contributions with open arms. But if nobody wants to do these things, they won't happen. This is not a commercial language. This is a volunteer language.
One of the features we actually get with 26 is that we have now linear algebra in the standard.
Yeah, we do.
And I know that you have a paper in that direction and you're not directly involved with it, but I know that that is kind of your thing, right? You're coming from games programming, and that's something nice for those people too.
Yeah. Well, it's not quite something nice for games programmers. So the linear algebra in C++ 26, and I'm speaking as a mathematician. I'm actually a mathematician. I'm not a computer scientist. That was my minor was computer science. My major was maths. The linear algebra that we have in C++ 26 is a set of C++ bindings for the BLAS, which is a old battle-hardened linear algebra library that was originally written in Fortran, I believe. And that's great because this addresses the point I was making about interoperability. We now have a way of a standard way of invoking BLAS functions from C++ code. It improves interoperability. That's great. I like that. It's no use to me because one of the things what BLAS does is the objects will all live on the heap. They are dynamically allocated. Tiny matrices, tiny vectors. So that's with 2, 3, or 4 element vectors and 2 by 2, 3 by 3, 4 by 4 matrices. You can cram those into a couple of registers. So they are suitable for automatic storage and for passing through functions, by value rather than by pointer or by reference. And that's something that I want to put into C++ 29, is those small things. I did have a proposal targeting C++ 26, P1385, if you're following along at home, which was a proposal to add linear algebra types of static and dynamic extent. But we ran into some really tricky design problems. I co-authored this with Bob Stiegel, who absolutely worked like a Spartan trying to get this to work, but we just ran out of steam. If anybody feels like taking it on or fixing it up, that would be great. But my next priority in linear algebra is getting the small stuff in so that, game developers, simulation developers, people developing simulations will be able to write code that will interoperate with other people, with other developers. Can I plug floating point? Have we covered that, or does that come later?
We can cover that, yeah.
Okay, because it's relevant to maths, you see. One of the big problems that we have at the moment in C++ and in C for that matter, particularly in C++, is that although a standard exists for floating point arithmetic, it's called IEEE 754, and it's imported into the ISO ecosystem as ISO 60559. There we are, ISO 60559. Is that we don't explicitly explain in the standard how we import this floating point standard into C++. So in the C programming language, the standard contains Annex F and Annex G, which is this is how we do it, and this is how we do complex numbers, and that's great. And we've kind of relied on the C implementers to lead the way, and so C++ implementations are often built on top of C implementations because there's a very large amount of overlap. But we need to say this properly ourselves. So another of the projects I'm working on, because I've got nothing better to do with my life, is writing this annex. I'm going to be recruiting people to help me with this. It's a big old job, I can tell you, but it is writing this annex, and this in itself is all part of my push towards reproducible floating point arithmetic. Because another problem that we have is I can write a piece of code on one. I can write some floating point arithmetic on and put it through two compilers, and I can get a different result. And that's maddening. That is enormously infuriating. Because from the outside you think these are deterministic machines. What's going on there? Why are you what? It defies. It doesn't defy belief when you think about it a little bit, quite closely.
I know you gave a talk about floating point numbers. I found that quite entertaining.
Yes.
It's like, right, there's the usual problems with them, but then, you go into the details between different systems, and that things even beyond that are not like what they seem.
It's a horror show. So that's another thing I want to fix. So I've got quite a lot of work for myself for the next 3 years, with arithmetic. I'm a mathematician, as I say. I'm not really a computer scientist, and I can bring my mathematical expertise, such as it is, to bear on the standard. So, I think it's, I do want to sort this all out, because, floating point arithmetic is used everywhere. It's used in climate modeling. We have climate scientists. I've been contacted by people from NOAA, the Americans from NOAA, saying, please keep up the good work. This is really, really important, because, again, interoperability is absolutely. If you've got a program that models some climate, we're in a situation now where you used to write a piece of code and say, right, here's the hardware to run on. Boff, there we are. Write your software for this. Boff, right. Turn the handle. Run the simulation for a few hours and see what happens. But now we're in the situation where people will spin up instances in the cloud, and they'll say, right, run it on there, see what happens. And you don't know you don't actually know what you're going to get. And so all the floating point calculation, and we're back to where we were with Mandelbrot spotting climate calculations diverging back in the 60s. We're back to where chaos started. And I really, really want to fix this. I'm a Green Party member. I'm a member of the Green Party of England and Wales. I stand for election in local council elections. This stuff matters. If I can make climate science that a little bit better, I'll be delighted.
ISO is not a political organization.
It's not a political organization, but I'm a political.
Actually, I do have a comment or a question from LinkedIn. So let's take an audience question. So, hello, Guy. As we integrate more AI tools into our C++ workflows, these tools often require high privileges to access our environments. Do you think we need stricter ISO level standards for the security of the built environment itself to prevent secret leakage during the compilation of AI-driven projects?
Whoa, that's a question, isn't it? Well, okay, so the easy answer is that we standardize the compiler. But that's a very weak answer, because we have a group called SG15, which deals with tooling, and that's build systems, packaging, modules, obviously features into all of that as well. Let's keep on the interoperability theme. It would be good if we could all agree on how our build systems work and how our security works. I am not an AI user. I have to say this. I've tried it out. It hasn't worked for me. That's just me. So I can't speak to AI deployment and operation with much experience. I'm sorry, what was that? I lost you there.
Yeah. I think that we kind of, I think this is a good question to talk about what is outside of the standard, right? And what his opinion on that would be. I mean, we can put something in the standard, but maybe ISO then says, well, that doesn't belong in our standards because it's not part of a programming language.
That's a very subtle question, actually. So SC20, oh, right, how far do we go here? So WG21, that's C++. WG21 is a working group of Subcommittee 22. Now, Subcommittee 22 deals with operating systems and system software and their application development and their application environments. So technically, build systems are within the purview of SC22. There isn't explicitly a group that deals with build systems. There could be. I think we could possibly start to spin up a working group. I'm not doing that. I'm too busy. I'm having so much fun with C++. Build systems, an entire new working group is beyond my reach, frankly.
Yeah.
But we could, but we do declare, we do say, look, this is the C++ standard, and we can decide, okay, the C++ standard now also contains command line stuff. One of the reasons why other languages, Rust is successful. They've got this whole crates thing. It's great. That's because they've incorporated all of that into their standard. And also their standard is, what they say is they're releasing a new version of their standard, pretty frequently. I'm actually going to the Rust all hands meeting in Utrecht at the end of May to say hi, see how things are. Because interoperability, as I've said, is really important to me. We need to interoperate with all of these languages, and I want to see how they do things. I want to see what we can learn from them. I think it's pointless being tribal about language. It serves no one at all. I'm in pursuit of engineering excellence.
Great. Hang on to the next question. Because let's go to the next audience question.
Okay.
So what do you think about STD-Zim, which is also C++ 26 feature, dead on arrival and just 10 years too late?
Oh dear. So I spent a lot of time in the numerics group, SG6, and we did a lot of work on this. I don't think it's dead on arrival. It does the job. I don't make much use explicitly of SIMD in my day-to-day role, though. So I'm hard pressed to properly assess that. I think the users will decide that. They will feed back to faults in implementation or something like that, and they will give us and they will give us feedback. You are always, and I can't stress this too much, you are always at liberty to contact your national body and say, can you tell WG21 to sort this out, please? This SIMD isn't working because of this. That's they love it. Your national bodies love it when you get in touch with them because it means that they feel that they are actually doing their job and representing you, the general public. A national body is a sovereign body that responds to the wishes of the nation it represents. So do get in touch with your national body if something's wrong. One person can do it. One person can write to a national body and say, can you fix this, please? Nothing beats that, that sense of validation that actually you're doing what people want. National bodies can get quite inward looking. I'm sorry, drifting off the topic here. So I don't know if it's 10 years too late. It took a long time. I know that much. I don't think it's ever fair to call something dead on arrival. It does the job that it was designed to do because that's how our process works. I think users will decide if it's too late. Personally, it looks fine to me. But as I say, I'm not a heavy SIMD user. But I know that the person who designed it, Matthias Kretz, he's a smart man and a heavy user. So I think he's the person to confront with that question. But I would not like to say either of those things is true.
And I think that's completely fine if you don't know the answer to a question.
Yeah. As I say, I'm not the best C++ programmer in the world.
Cohen asks...
Hey, Cohen, hi.
Is it correct to say that the performance C++ solution is also more power efficient in general?
Maybe. Yeah, now performance per watt is great. This is a great measure. I think that a performant C++ solution is one that does what you want it to do. So when you have a problem to solve, you have a set of constraints. You say, I've got a CPU, it runs at this frequency. I have this much RAM. I have this much offline storage. I have a 10-base-2 network card or something like that stuck out of the back. And performant means that it does all the things that you want within the hardware constraints that the system is operating in. But it is certainly true to say that the power efficiency of C++ is unmatched. Nothing is as efficient, to my knowledge. Nothing is power efficient. The performance per watt of C++ is unbeatable. I'm sure other systems languages, I'm sure C and Rust probably get there. But one of the things that C++ does that those languages don't is the sheer range of abstractions that they offer. The way that those zero-cost abstractions compile down to the code that sips the least power. So, is it correct to say that? I wouldn't disagree with that. I would not complain if that turned up in some course notes on a C++ degree course.
I also think it's mostly true. I can see like potentially counterexamples where if you spin up the GPU for a single problem and you use a lot of power there potentially.
Oh yeah, I've got another 3090 in here, and the fans on that alone, use up so much.
So, but I guess generally it's true in any environment where you use GPUs, you have the GPU running anyways as part of your power consumption. So this thing is again true, but I think it's a nice way to think about it.
Yeah, absolutely. I mean, GPUs, they're big hefty beasts. They have all of these things. They have a place. They solve a particular problem. If you're using the wrong tools to solve your problem, that's going to cost you performance. That's going to cost you energy. It's going to cost you time. It's going to cost you all those things. The engineer is the one who calculates the best trade-off. It's like cheap, good quality, on time, pick two.
Which two do you pick?
No, I pick all three, but that's just me. No, I assess my clients, and I say, okay, let's see what's going to work here.
Yeah.
It is a very human. Engineering is a very human activity. I know that programming is deterministic and mechanistic, in fact, and that we are striving to automate so much of programming so that we don't need to think about it. So machines will make the right decisions and the right choices. But ultimately, engineering is a human endeavor. So I have a problem to solve. Tell me about your problem. Well, there's this and this and this. And you look at them and you think, okay, for $100,000, I can give you this. That's basically how it works. That's engineering. It's all trade-offs.
Mm-hmm. So talking about engineering trade-offs, and there's, of course, maybe we should also talk a bit about what you do at your day-to-day job. So here's an audience question about what daring C++ challenges are you tackling at 6 Impossible Things Before Breakfast? Are you using any C++ 26 features that others like UA5 don't dare to use?
Oh, well, what an excellent question. What are we challenging? Well, so I am the head of engineering at a Ukrainian. It's incorporated in Ireland. Most of our team live in Kyiv. And I'm fully remote. I've not been to Ukraine. There's no airspace there. So, it's kind of out of bounds for me, really. But I'm the head of engineering there, and we are making a game engine. We are targeting the Unity space, is probably the best way to describe it. The 6 impossible things, well, we haven't listed 6, but I can tell you one impossible thing that we're working on is all of this floating. Reproducible floating point arithmetic means that we can write cross-platform multiplayer simulations. And that's one of the things that we want to challenge, that we want to tackle. That's probably, well, for me, that's the headline one. But we're also, investing in profiles. We also want profiles to work. We think they're really, really important. Writing safe, easy C++ code is important to us all, to the extent that we're putting our own money. Well, my boss is saying, right, I'm going to devote these resources to making profiles work. That's great. The world needs more bosses like that actually give back to the community. This is absolutely what's needed. Are we using any C++ 26 features? Well, one of the problems of writing a game engine is that you've got to write code that will be read by many compilers. So, you know, we're rather limited on what we can do. We're at C++ 23 at the moment. I am itching to get some reflection in there, because anyone who's ever written a game engine will know that at some point you end up reflecting on your enums or something like that, and or for file IO or stuff like that. And you just see so many variations of the same piece of code in game companies. And again, interoperability, having one way to do it will just simplify everyone's lives. So no, we're not using any C++ 26 features, but we are in a better place to use them than other game engines which target consoles. They're always the last to catch up.
That is true. And I've recently worked on the trends feature for the survey and also for the data from the candidates I have over the years. And yeah, C++ 17 prevails, but we can see in the recent years 20 becoming more popular.
Yeah.
So actually, audience question, and we're back in reflection. Are there plans to add more support for code generation facilities to C++ reflections in C++ 29?
It's a priority. We're waiting for papers to be bought. I know the reflection team aren't sitting back and chartering yachts to the Bahamas and lying in the sun. They are busy at work, wants to carry on and wants to push on. So yes, code generation. I would be astonished if there's no code generation facilities in C++ 29. Can't be explicit about it because I haven't read the latest mailing. And this is, I have to say, this is an important part of being in a committee, is that there are people who are experts and that I simply rely on. And I say, well, do you know what? I can't know everything that's going on. I can't read every paper. I've got a day job. I have a day job. And this is an important thing that people need to realize. I'm doing this in my spare time. My boss is very kindly sponsoring me to attend meetings and to work on stuff, but I do actually have a day job. So I can't possibly read all the papers, comprehend how they all interlock together. And I'm a switchboard at best. Yeah. I can direct people and say, oh, do you want to know about reflection? Oh, you'll be wanting Barry Revson or Daniel Katz or something like that.
That's what you have chairs for, right? And you have the subgroups and you have chairs which do this kind of work.
Absolutely.
You're more the head of the organization which is organizing.
Yeah, I delegate authority to the chairs of the study groups, and they act in my stead. They call meetings the subgroups. They call consensus on votes, and they advance papers up the chain. Ultimately, I call consensus at the top at closing plenary, but I'm not. I delegate all that authority away. I can't run the whole thing. I've been to a C meeting, a WG14, and Robert Secord is there doing everything. He just does the lot. And I'm thinking, whoa, how do you manage? Honestly. But yes, I delegate everything away. So I'm sure we will see code generation in 29, but because I don't read all the papers, I can't tell you exactly what's going on. I'm going to carry on, reading as many papers as I can.
Yeah,
I rely on the expertise of all of the committee members, and I trust them. I assume they're acting in good faith. I assume that my chairs are shepherding things through correctly, and it's quite a relief. It's rather like an API. You've got an API, and you say, right, I'm not going to bother seeing how this API is implemented. I'm just going to call it and trust the documentation and trust the engineer, because I'll know if they've got it wrong.
So as far as I can say, yes, that is the plan, to have more facilities for that available in 29.
There's
because right now we are only able to, when we talk about code generation, we effectively only are able to generate aggregates. And so this is very likely to be expanded, but at some point, basically the features had to be frozen for 26, or we would not have reflection, which is already very big and very nice that it still fits in the standard.
The feature set is frozen for 26. That's gone out now. So you can download a copy of the working draft, and you can see. You can
second part coming for the next standard for sure. and that will extend code generation for sure, I think.
Yeah, the whole metaprogramming is a constant, constantly growing feature in the language, and it's not going to stop because it takes us. It increases abstraction. It just makes more abstraction available. It just increases the power, the power of the abstractions that we can make.
True. And let's move on. That's actually an interesting question. Have there been any new thoughts on the long-standing ABI issue of C++ that stop fixes, improvements on SVD containers? That's a fair question to ask.
Yeah, it absolutely is a fair question. No, there have been no new thoughts. Backwards compatibility still seems to be king. Yes, if somebody might propose a new hash map, it could happen. I'd welcome that. I'd welcome a new proposal for a hash map that doesn't suffer the same problems as the others. And new containers have been proposed. Std Hive has gone into C++ 26. That's actually my favorite. That's probably my favorite immediately usable thing. As a game developer, Std Hive is a new container that I've been using for decades, but now it's got a name. It never had a name. Now it's got a name and again, interoperability. Now I know I can say to people, "Oh, well, just put a Hive together. Put all your entities in there. You've got a Hive full of entities." I run, don't walk to your implementation of Std Hive and take a look at cpreference.com or look at or search for. So it's based on a thing called PLF : colony by a chap called Matt Bentley. And honestly, it's about time, really. Why has it taken us this long to get this thing into it's a thing like this into the standard? It's quite a long journey. I think it's a good 10 years in development, but we have it and it works and it's great. But as far as ABI is concerned, no. We can add new types. We deprecated auto pointer. We deprecated the thing because it didn't work. It was not fit for purpose. Particularly, once we added move constructors, once we added move semantics, auto pointers, they are toast. And we replaced it with unique pointer and shared pointer. And in the same way, we can add new containers that do a better job. We're not shy about growing the standard. As I say, it's 2,600 pages long. That's a lot, but it's the right 2,600 pages. Stuff will fall out of fashion. I haven't seen a std list in use for decades. It's probably the 90s, the last time I saw a std list. No, probably the noughties, probably the 2000s was the last time I saw a std list. But in my line of work, people just don't use std lists. There's never, you've got to use tens of thousands of elements for a std list to become more efficient than a std vector. But it's still in the standard because of backwards compatibility. You might be compiling 20-year-old code, 30-year-old code that requires, 28-year-old code that requires a std list. So it's still there. So no, there was a meeting. So C++ 20 was shipped in Prague, and in that meeting there was an evening session where the entire committee met and said, right, we're going to solve this once and for all. What's our priority? Backwards compatibility or ABI breakage? And it split down the middle. It was like Brexit. There was clearly no overall winner. And it was very frustrating.
A few years ago, a proposal which actually kind of tried to solve this Gordian knot with a language feature which would then basically give us conditional blocks to say this block is only valid from this standard or this version.
I think this was Vittorio. I think it was Vittorio who proposed something like this.
He proposed something similar either, or it was his proposal, or he was related to it. And I think something like that as a language feature. And I remember that at C++ Now, maybe that is a C++ Now keynote that was online, Bryce hinted at that paper. And that went nowhere. And I think that, if you really want to be challenged in C++, that'd be the feature to work on.
Well,
But the ability to break ABI and to define ABI as something new is gone. It's like ABI is part of the vendor train. It's not part of the standard. And
if somebody wants to bring a paper, if somebody wants to bring a new paper that will convince us, that's great. I look forward to it. One of the problems with contracts was that some really smart people don't like contracts and they're really worried about it, but they failed to convince the rest of the committee. That's what you have to do. You've got to convince the committee. Because if you can't convince the committee, it doesn't matter if you're right. If you don't persuade the committee, it's not going to get in. The committee is a consensus-based organization, for better or worse. It's very difficult to say, well, no, you're smarter, so you get a stronger vote. You can't say that. That's not how these things work.
And in case you have any free time left.
In case I have any free time left. I'm working on another book, although it's honestly, it's not quite in limbo, but it's certainly, hammering on the door of purgatory right now. So my next book is The Game Developer's Guide to Learning C++. I think it's impossible now to write a book that will teach all of C++. Maybe Nico can do it, maybe. But I just think publishing it in a single volume would be hard work. It'd be an absolutely giant volume, or maybe it'd be like a Bible, really tiny, really that squinchy paper with tiny print on it. It's so a direct follow-up to Beautiful C++. Kate and I chose those topics because she'd already spoken about them, and we thought we could write about them quite easily. And honestly, we knocked that out quite quickly. Finding another set of topics to write about, it feels like looking back. I'd like to write something a bit more close to home. I'd like to write something for game developers to learn C++. I don't want to teach C++. I want to teach people how to learn C++, because there is a mindset, there is an art to learning C++. To understanding all these arcane things, to understand why type deduction is important, to understand what the abstract machine is, what the memory model is, what all of these words and phrases actually mean. Those are the things that need teaching. Once you've taught those fundamentals and the rest kind of falls out, it's much easier to teach people about references and reference collapsing once you've taught people the importance of type and type deduction. It's that sort of thing. So that's the book I'm working on at the moment. But as you can imagine, time is tight. Because I also play the piano and campaign in local politics. I sing in the chorus. It's just not quite bubbled up the priority list enough. Maybe in the summer, I don't know.
Really the problem. I started writing last winter, and I'm now at 86 A4 pages about C++. There's lots of examples, and I look forward to releasing some of that on the blog. And at someday, that probably also, once I'm done to proofread things I have, then I'm probably gonna also publish this as a book in the future.
Yeah, do you know what? We need more books. We need more writing. We need more teaching materials. And we need up-to-date teaching materials. We're releasing a new standard every 3 years. That means some teaching materials become out of date. Some teaching materials are completely absent. I've yet to see any good teaching materials on stud execution. It's a complex topic. I've seen some great blog posts about bits and pieces, but I've not seen something that, for the beginner to say, why do we have it? What motivates this feature? How do I make the best use of it? It's troubling. One of the things we could insist on in a proposal is not just the proposal itself, but also describe the teaching materials. What are the teaching materials that should accompany this proposal? How should we teach this to various levels of user? I don't want to put too many. What's the word? I don't want to be a gatekeeper. I want people to be able to. One of the great things about C++ is anyone can write a proposal and they're entitled to be heard. That's how ISO works. We're not allowed to tell people, no, you're being an idiot, get lost. I mean, if people send us vacuous proposals, then obviously we can do so. But if there's a sensible proposal, I can direct my chairs to say, look, this has the workings of a good paper, but you need to do this, this, and this. And once you've done that, we can present it to the committee. But we can't just turn stuff away. So I love the democracy of C++. I love the accessibility of it. Anyone can come in there and fix stuff up. I always encourage people so to do. We've got a really enthusiastic, quite welcoming team of people. The committee is huge. It's got a diverse age range. We've got diverse gender representation, more so than I expected when I first got there. I love it, really. Yeah, come and join us. Join your national body. Come and see me at committee.
That is true. Next meeting is in June.
That's right, in Brno, June 8th to 15th. No, 8th to 13th. Oh, I don't know. Yeah, the second Monday in June, I think. Yeah. I don't know. I'm going to be in Japan the week before, which is slightly awkward. So I'm going to turn up there with horrible jet lag. But yes, it'll be fun. Yeah, Czechia is nice. I'm going to be seeing Hannah. I always love spending time with her.
Yeah, in June. Sounds like a nice. We've talked about adding things, but we haven't talked about removing things. So,
what I'd like to deprecate.
You'd like to make use of deprecate in C++.
To be honest, I'd only like to deprecate things that are dangerous, or things that have become dangerous, or things that are misused. Volatile. That was one of those. So what does volatile really mean? I don't know what volatile means. I discovered long ago that I don't know what volatile means. I thought I did. I was wrong. And there have been papers about volatile and its deprecation, and oh no, we need to reintroduce it. And oh god, what should we do now? So I'm very, an auto pointer was deprecated because it no longer worked. Once we had move semantics, it just stopped working. So I don't think there's anything I want to deprecate because deprecation affects backwards compatibility. Once you deprecate something, and suddenly code that used it that was written in the 1990s will stop building, and that can be bad. You have to take deprecation very seriously. So I would be, reluctant with my deprecation and generous with my inclusion.
Yeah, I think that's a good way to end the interview. If there are not any more questions, post your final questions. We already had a ton of questions, and I don't know how much more time Guy has.
I can give you another 40 minutes, I think. I set aside 3 hours.
That's a bold thing to say.
I don't know how many people are out there. All I can see is you and me. I should probably join Hubelo or something like that.
There's a few folks watching this.
Okay.
I noticed that when we talk about standardization, it not always attracts everyone, but there's some interesting people watching.
I used to be radio broadcaster.
I wonder if they have any more questions. And there's a nice selection of people in here, which I know, which I've seen, which you have also met. And
no, I used to be a radio broadcaster. One of the things about being a radio broadcaster is you have no idea who's listening. You have no. I could be speaking to 10 or 10,000 people. I don't know. It's quite joyful actually having somebody I can see. Right, I'm talking to Jens. I'm going to talk to Jens about C++.
Yeah.
Jens, whom I've known you for what, 12 years now, I think. So I think 2014 was the first one I came to. So yeah, 11 years. Yeah.
So, of course, I mean, will you submit the talk? Will you?
I will submit the talk. I am deciding what to talk about because things are up in the air at the moment. You see, I could do a talk about profiles. I could do a talk about floating point, or I could just do a talk about what's coming up in C++ 26. I wonder if a C++ 26 talk is actually old hat now, because I think we did all those last year. Maybe I could do a talk about stood execution, what motivates it and what does it. I'm still playing with all these ideas. to be honest, talking about floating point is absolutely my specialty. Maybe I could do that. I'm brewing up some keynotes. I know you've got your keynotes filled up, but I'm brewing up some keynote talks as well, because that's the kind of thing that people will do. I've got a keynote on abstraction and recursion and the general sort of the philosophical underpinnings of the mathematics of computing, which is coming along quite nicely. So if anybody wants that keynote, do get in touch.
We'll see. You had some very nice ideas about talks there. Generally, I think 26 will be the big topic this year. We did not have so many 26 talks yet. Like we had, I think last year was a reflection talk. I think there was, yes, but it was more like we solved this problem with reflection, which was a nice, but there was no introduction into reflection last year at the conference.
I do recommend
thing to do this year, but talk about profiles, the other ideas, just submit them all and we'll see what the audience wants to see, right? And
maybe profiles is the talk to give. Safety is the trouble with floating point is that it's a bit niche. It's a bit propeller head. It's people look at SG6. The study SG6 is the numerics group. And like people look at us and they're going nerds. All of these people in the C++ community, they look at us and go, oh, no. Because we in SG6, we look at core and we go, oh, nerds over there. There's degrees of rarefication, if you like, within the whole effort. But I think floating point is a bit rarefied. Whereas profile safety does affect everybody. Maybe I'll do that. I presume it's one talk per speaker, isn't it?
Mostly. It depends when we have fun again. Then I just submit your ideas and we'll see what sticks with the audience, and then you can do that. And
I would love to come back and speak in Berlin. I absolutely adore meeting C++ conference. I've been to almost every one since 2014, and it's just I love Berlin, and I love the conference. I love the people, and I love the Andels Hotel. It was the first place I took my girlfriend to in 2011 after we started dating. She's now my wife, and so I was delighted to find a C++ conference in that very same hotel.
Yeah, it was a good pick to be there. I still like the Andels after all the years. It's amazing to be there every year. And generally, so conference is out. You've been a long-time speaker, not every year, of course, because sometimes the committee has a strange thing to meet in parallel to my conference.
It's really hard, scheduling. This is something I found out. Scheduling the committee, the constraints you operate under are getting tighter and tighter.
I know. It's difficult.
And this year we're meeting later in November. Yeah.
And this year first it was like for me, I thought the date is nice. It's at the end of November, first Advent, Christmas time. That's very good. But when I started asking for keynotes from the Americans, I very quickly got the feedback that, well, that's Thanksgiving and it's not very popular for us to be in some other place. And so we'll see. I already know of one American which potentially is at the conference, and there surely will be not only one. And with keynotes, I have two, and with the others, I'm not sure right now. Conferences are in a tough spot right now, so we'll see what we do with the last slot, and potentially if we have something in the evening. I don't have any announcements there yet, and I have still some time to think about things.
No, I look forward to seeing it. The thing I like about the meeting C++ keynotes is the time that you give them. So I'm the chair of ACCU. We give our keynotes 75 minutes. I'd like to give them more, but it's not possible. But seeing people spend 2 hours properly developing a theme, and putting just everything out on the table, it's remarkably satisfying. I think it's a great feature. If you're going to get a keynote speaker in, they're an expert speaker. They're totally capable of speaking. They've mastered the craft, and so asking them for 2 hours shouldn't be a problem. And indeed, they should relish the opportunity to, properly say, just lay out the. It's very rare you're given that kind of platform to speak, to deliver your message. I always enjoy the keynotes.
To be fair, not to have all my keynote speakers in the future terrified it's 90 minutes, which we say.
Okay, all right.
The original 2-hour reason is that the first keynote has to include a time buffer, which is when registration runs late or there's other technical problems. And I think you've been there when Kevin Henny keynoted, and we have this really bad problem with the projector. And it was like, and then one of the most amazing things I've seen live, and Kevin was just handling it, and just people actually asked after what if it was like planned, or did someone like turn it off and on purpose or something, but no. And
that was a stunning moment, wasn't it?
We never have that problem again. The tech crew will make sure that this project works always, but that was something else to see.
Are we still on 2 floors this year?
Technically, yes, we are on 2 floors.
Yeah.
We've always been on 2 floors. The 3rd floor and
the downstairs. Right. Okay.
There used to be a time where conferences were big.
Yeah.
That's when C++ and Meeting C++ grew. But now with all the other conferences in Europe, and that's because they said it's 9 or 8, and that's true. Terrifying to think about that, and I think it's kind of, especially with have you noticed what is happening in the world this year and last year? It's getting tough to organize conferences and to reach the necessary audiences.
It is. I think when you decide, right, I'm going to do a conference, there's a lot of things to think about. The cost of doing it is considerable, but also the effect on the rest of the community. Every conference you start up, that's suddenly you're giving the community more places to go to. You're going to dilute through the remaining conferences. You need to make that decision carefully. We've got. I'm delighted there are conferences to go to. I really am, in all sorts of places. C++ has taken me around the world. The conferences and the committee, and it's been absolutely amazing. I've enjoyed excellent sponsorship from the C++ Foundation and from all the conferences. It's been, it's been the highlight of the past decade of my life, frankly. It's just the amount of travel I've done, the places I've seen, the people I've met. But, you don't want to kill the goose that lays the golden egg. There can be too many conferences that can actually have a deleterious effect on the community. It's a tight line to walk, certainly.
I do think that will sort it out itself out over time.
Oh, the market will decide.
Yeah. C++ right now it's tough, and we'll see. I have to adopt, and that's why I started producing my own content. So I will go more into teaching and putting more stuff about C++ in front. Also tried to pivot into hiring, but hiring is so difficult to get anyone interested right now. So I hope to see.
Yeah. AI, people have got to work out what AI is for, and once they've worked out what it's for, hiring will restore. I think the people who are making the hiring decisions aren't engineers. I think if engineers were making the hiring decisions, they wouldn't be saying, "Oh, we can get some AI to do this," because they all know that AI doesn't work like that. You still got to check your work. You still got to take responsibility. AI doesn't absolve you of anything. It doesn't absolve you of any responsibility. It just means you're doing the dull stuff now. This is what I'm observing with many of my colleagues. I mean, not at 6 Impossible Things Before Breakfast, but around the community in general. is that the AI is doing the interesting bit of the problem solving, and they're doing the tedious bit of the checking its work, and that seems wrong to me. You want to use AI elsewhere. You can put it's like getting AI to draw pictures and write poetry. No, that's my job. I'm the one who draws pictures and write poetry. You're the one who does my taxes. That's what I want AI for, to do all the dull things I don't like doing. But that's just a pet hate of mine.
Yeah, I think it will be interesting. We're probably entering the age where AI will have to charge its true cost, and that we have to face those data centers are not coming online, and the bubble will, in one way or another, burst this year probably. Or
I think there's certainly going to be a correction in the charging. The effect it will have on the AI ecosystem is to be decided. There are some terrifying amounts of money swirling around, except they're not amounts of money. It's not real money, is it? It's value rather than cash. There are some terrifying quantities and sums being described. There's that's going to be a dramatic unwinding, I suppose, is probably the best way to describe it. But that's a good thing. The sooner it happens, the sooner the true value of AI is realized by the market, then the better. It means we've got a more sensible way of pricing that effort. There's part of me that wonders: are we using this magical, enormously powerful tool for really trivial things? Something so expensive. Are we just using it for really small things? Do we need to be much more mindful of where we put AI to work, so to optimize its value? We don't see the cost of AI. We don't see it in terms of the amount of power it uses, the amount of water it uses.
I'm sure we will see that in the future.
I hope so.
Let me pivot to a question. You talked about teaching C++, and I think it's something which probably interests people. So maybe we should, if you want to still have some time to talk, then that's, I think, a topic we're spending time on. What are your ideas? How have you teach C++ in the past, and how would you address it in a book or something?
Okay, so the first thing to say is I've never taught a structured C++ course. So I'm just going to say that right at the start. This is part of an interest of mine. There are people like Titus Winters. They know how to teach. They know how to teach languages. They know how to teach stuff. He's well qualified to do that sort of thing. I, on the other hand, I can give you like little 5 and 10 minute snippets, and even 40-minute, 50-minute, 60-minute, 90-minute lectures about aspects of C++. But teaching the whole thing, that's quite an undertaking. I would teach C++ probably by teaching the hardware. C++ is a programming language. You're teaching sounds to dance. That's what you're doing with C++. Okay, you're showing microprocessors how to wiggle their circuits around. So people need to know about the hardware, and then you just teach it by abstraction. The main thrust of the notes in my book, as it were, you start with abstraction. You say, okay, look, here's registers on a CPU. And so how do we represent registers in C++? Well, okay, we have types. We have built-in types. We've got integer, and we've got float. And here's how integer and float work. And so you built that abstraction. And you say, okay, we've also got instructions. We have an instruction pipeline. We've got an ALU, an arithmetic logic unit. And so I would teach and say, okay, so we put data in there, and then data comes out at the other end, and that's called an instruction. Then we abstract that with things like plus and minus and equals. And then we've got flow control. And you build up from the processor. You build upwards. And you can evolve the teaching as you evolve the processor. The first processors really, they didn't have memory management units. They didn't have multiple cores. So, we don't talk about that. But teaching by abstraction. Because the great thing about teaching by abstraction is you can reflect the problems that have been solved, and you can also take a historical perspective. And I think there's a lot to be said for teaching anything by looking at how did we get here. When you teach physics, you teach Newtonian maths, Newtonian physics. You teach Newton's laws of motion. We know now that obviously the relativistic model is more accurate, but you still teach the Newtonian stuff because it's easier. You still teach that. So I take a historical approach. I build up the hardware and build up the parts of the language that reflect that. There are some things that are fundamentally you do have to start with, like type. Although I suppose no, with type, you're teaching about memory, aren't you? How are objects represented in memory? Oh, well, there's a type. Oh, tell me about types. Well, types are great. Types are entities that have sets of values, some of which are legal and some of which are not legal. So, like all values in an int are legal, not all values in a float are legal. Some values in a float, like nan or inf, kind of break things. Or you have classes that are types that have invariants. And you, as a designer, you get to say what these invariants are, and that's what's the useful thing. You're abstracting the complexity of the thing that you're modeling behind this API. All these invariants, they just keep everything sort of like nice and tidy, and you don't need to worry about it. Abstraction's all about hiding complexity, and I think that's what I'd be doing. Is I'd be teaching how to hide the complexity, how to keep writing simple, beautiful code. Now, this was the thing I discovered writing beautiful C++. Was that by far and away the core guidelines, they're all about just work at the correct level of abstraction. That's just been the most extraordinary thing I've learned this decade. And I always knew it, but I wasn't able to properly articulate it. So I'd be teaching, I could call the book Learn C++ by Abstraction. That might be a more accessible title, I don't know. But maybe there are more game developers out there than people who are interested in abstraction. But that would be my approach, to evolve the hardware and evolve the language to meet it, and to evolve the problems that we want to solve. In a nutshell, I could go on, but
Yeah, we've had last year at meeting C++, where Slobodan Dimitrovic spoke about teaching going from intermediate to senior, more or less, or was it like from junior to intermediate? I don't know, but he did a great job, and it was definitely an interesting talk. And yeah, so I think anything else you want to talk about? Any topic we haven't covered, or which comes to your mind, which we should talk about?
Talk about Hive, floating point, linear algebra, 26. I'm not going to talk about the bureaucratic process of landing a standard. The disk goes out, national bodies vote on it, we carry on. No, we're all good here. I do want to thank. First of all, I want to thank you for running Meeting C++ for so long. It's a great conference. You should carry on doing it. And if you need help, call upon me. Okay, I would be delighted to help ensure the conference continues. But also, I want to thank the people that run the committee with me. All of my chairs, all of my vice chairs. I have a convenership team. The first thing I did when I became convener was I said, right, I can't do this alone. I'm not Herb. Herb is this peculiar unicorn who's brilliant at all things and just gets stuff done, and I asked two people to join me as vice convener so they can step in as convener. We share the load. It's so much easier. That's and Nina Rance, and they're my vice conveners, and I'm very grateful for them.
So you already started growing your successors and training them.
The first thing you should do when you take on a job is train your successor.
I don't want to ask you how long you plan to be there. Herb was for a very long time, and I really think that it's nice to have someone else there with a lot of experience.
The first thing you should do when you start a job is train your successor so you can leave without leaving a bad taste in everyone's mouth. If a great opportunity appears, then you can just leave it and say, well, fortunately, I've been training this person to take on. The convenership term is 3 years. I will serve for 3 years. I might serve a second term. I don't know. I'll see how I feel. Maybe it'll be Nina's turn or Jeff's turn. We don't know these things until further down the line. I'm 58 years old, and I certainly couldn't serve as long as I can't serve for 22 years. That'd be fatuous. I might be able to do 3. Well, I might be able to do 6 years, but I don't know. I don't want to make those decisions. I don't want to speculate. There's enough to be doing now than worrying that far ahead into the future. It was nice. I've got to say, it was nice calling consensus on C++26. That felt pretty groovy. I wouldn't mind doing that again for C++29, but that would mean running a second term. So we'll have to see.
Oh, yeah, that's
because it's a 3-year term and it's a 3-year cycle for the standard as well. So each convener gets to, if each convener serves 3 years, you get to kick off one. So you get to call consensus on one standard, and it's the one at the beginning of your term.
Yeah, that's an interesting problem to have, indeed.
It's not really a problem, is it?
Yeah. Let's say
it's an aspect of service. Leadership. It's all about service. All of this is about service. This is about voluntary service, and that's the important thing. I get an enormous sense of well-being and satisfaction from serving my community in this way.
Indeed, and
I'm sure you do too.
Yes, I do. It's amazing how many people are going to the committee, organizing these. Just to find people which are willing to organize these things, which basically have become conferences without conferences and take enormous amount things to ensure to happen. And so it's really nice to see that this has worked out. That actually, the whole idea which Herb had, the train model, and that this has worked for all the years, never broke, and always went on, even this pandemic going virtual, which still is something I think which will keep. And then also, there's these things which the committee is maybe not paying attention to, but which we can debate here in such an interview. Lumos asks, is object-oriented programming dying in high-performance C++ in favor for data-oriented design?
Nope. Next question. No. Again, the answer is a particularly subtle one. What's the problem you're trying to solve? Object-oriented. So probably a better way to refer to object-oriented programming is dynamic polymorphism. When C++ first launched, the polymorphism opportunities were quite limited. You had dynamic polymorphisms with the virtual function, and you had static polymorphism through templates. And we've done a lot of work on templates as the standard has grown, a lot of work, and that's made the static polymorphism options much richer and much broader, which means that we can now make these unknown decisions at compile time rather than at runtime. And that's great. Making decisions at runtime is expensive. You don't want to be making decisions at runtime because that's a branch misprediction waiting to happen, So comparing object orientation against data orientation, it's I think you're comparing, apples and Thursdays there. They're different things. I think object-oriented programming it reduces the number of moving parts, and data-oriented design reduces the size of it. There's some kind of model I have in my head about how data orientation works. I think they coexist fine. It's just knowing where the boundary is, and I think it's sorry.
I think it's something which we could potentially think about adding support for in the standard, because data-oriented design is something you have to do on your own or have to use a library for.
Well,
but if
I've seen people writing entity control systems in games, ECSs, and it's a paradigm. It's an idiom. It's not even a paradigm. It's just an idiomatic way of writing code. I don't know that there's language or library support that you need for data-oriented design. It's a way of factoring your code, of factoring your problem. You've got a problem, you say, right, how am I going to break this problem down? Well, I've got this and this and this and this and this. And great. What structures, what abstractions am I going to create to express all of this? And you say, well, I've got all of these. This is great. What data am I throwing around? You say, well, there's a whole load of data being tweaked all the time here. Well, great. Okay. What order is it being processed in? Oh, well, we've got to do all the positions. We've got to update all the positions of everything, and this dictates how you design your code. You know, there was a time when people were saying, "Oh, data-oriented design, that's the only way to fly," and it's not. It's a tool that you use in the right place.
The reason why I was saying this is there was last year a talk at CPPCon showing how to use reflection to turn structs into data-oriented design.
Yeah,
and
Vittorio again, wasn't it?
Yeah. No, it wasn't Vittorio. It was a reflection talk by, I'm bad with names. You know the person.
Barry Revson.
Right. Yeah. I love his work. Shout out to Barry. And he showed that, and it's an amazing talk, but it's one of those talks you have much trust to understand.
Yeah. I saw that talk, and I came away thinking there's something brilliant in there. I need to go and watch that talk another 5 or 6 times. Barry, the man's an alien. The man is so smart. He's so connected to all of this. It's a privilege to be in the same room as him sometimes, frankly, just hearing him be clever. There's something deeply satisfying about that. I don't know that it needs support. I mean, if Barry has truly demonstrated a way you can achieve it with reflection, then because this is one of the things reflection does. We can just rebuild the language if we choose. We have another. This isn't just abstraction. This is kind of abstraction squared. It's we are able to we can do anything. It's just freakish. Herb gave a talk last year saying it'll take us 10 years to work out what reflection can do, and he's not wrong. He is not wrong. We've been given the fruit of the tree of knowledge here with reflection. It's going to be an extraordinary time. I reckon Herb actually stepped down from the committee, so he's got more time to play with reflection. To be honest, I think that's why he did it. He said, "Oh no, I can't fully immerse myself in reflection and run this circus. So I'm going to step down. Some other sucker can do it, and I'm going to play with reflection for the next decade." That's what I do. I'm sure you didn't do that, by the way, just in case you're watching.
I am sure that you still will see Herb at the committee.
Oh yeah, Herb was there. He was there in Croydon. It was great to see him. And of course he can be a bit more free. He doesn't have to worry about the political ramifications of what he says. That's my job now. I have to be careful about what I say. Historically, I haven't been enormously careful about what I say, but it's I can do the job, and I'm I can keep things calm. But yeah, Herb gets so many likes now. It's great. He's a man off the leash.
Indeed. Well, I think that brings us to the end.
Excellent. It's been an absolute pleasure, as always, Jens. Thank you.
Yes, it's always. I really like those evenings to talk to all the great folks we have in the community, and I saw basically 26 is done, and from the perspective of doing things to it, now we just have to process it, and it would be a great opportunity to basically have you on and hear what the new top C++ bureaucrat has to say about.
I need a new T-shirt.
All the things. And so thank you for actually volunteering for this, because I know it's quite demanding to have all those questions thrown at you, and I think for the first time ever I was able to give you some of the head-ups of what we will ask, and it was really nice to have you here. So thank you.
Thank you so much. I really appreciate it. I really enjoyed it. Thank you. Anytime.
All right. And with that, thank you to the audience. Also, thank you for the questions. I've asked some of my questions, but also there has been a lot of audience questions and feedback. And so I guess on the weekend, this will be on YouTube. So thank you, Guy. And then we'll see where C++ takes us in the next 3 years.